Hello class, today we'll be going over the data wrangling notebook that is provided to us in Canvas. If you can find it, it's in the week 6 notes over here at the data wrangling. So let's see the PowerPoint first. Let's go over what's taught here. First of all, it's 64 slides, so I'm just going to skim through it. So data cleaning and transformation we talked about in our last video. Data wrangling is the process of removing errors and combining complex data sets. So we're basically trying to make it easier to understand for humans. It may be data munging process, reorganizing, transforming, mapping from one raw data to some valuable meanings and stuff like that. Why is it important? Have a look. Who doesn't like cleaner data, right? So machine learning model require a good data to be inputted, so they require some sort of data, so data wrangling is important for that sense. Data quality issues, we went over this in our previous lecture as well, so I'm just gonna go down and see if there is something new. Yeah, we've gone over this before in the previous lecture as well, so if you haven't seen that, just go over and see this previous lecture. But I just gave you a brief introduction of why we need data wrangling. Now download this notebook, the code.zip, and over there you will find this data wrangling file. So let me make this bigger actually first. All right, so the first thing that they did here is I'm just going to run this, and I don't have an auto.csv file. So first it should give me an error that's saying that I do not have an auto.csv file. All right, so let's go over back to this, and let me give me 1 second. I'll do this in this side. So let me open. I'm going to copy this. I'm going to put it in my uh, I got it. So I'll be opening up the Jupyter notebook and we'll be working on that. Alright, I got the file in there. So it's opening my Jupyter notebook and it's inside my projects and DSC 101 videos, and it's inside data wrangling, and this is the notebook that we're talking about. Alright, looks good. The code looks the same as well. So let me start by running the first code. Auto.csv, since they have this file in the directory, it's printing the head over here. Alright, now triple X. What is this function doing over here? Actually, yeah, let me make it bigger for you. Okay, so the function triple X will take any X and it will return 3 to the power X, 3 times the value of X. So print triple of 3, let's see what this will do. This did 3 times 3 and it printed 9. Triple of var times print 3 times var is 9, so 9 times 3 is 27, that's what it's printing here. And triple var of 4, so var times 4 is basically the triple of that. So 9 times 4 is 36, 36 times 3 is 108. Alright, triple print has, so it not only works for integers but it also works for strings. So 3 times ha will print ha like it did here, and list 1 is 1, 2 and 3, and if you print a triple of list 1 it's just going to print it for 3 times. Alright, now we are using numpy here for discussion, which we did in class as well. So f of s is a function that is returning this. Alright, it is returning the sum of s, which is the sum of the array, dividing each value divided by the sum of the array times 100, 2. Alright, let's see what this will do. A is equals to numpy.array 1. So let's take this 1 for example. What is the sum of all of these s? So over here our sum is going to be 1 plus 2 plus 3 plus 4 plus 5, which in this case is 5 plus 5 plus 15. So it will be doing 1. So our function for the first value will be doing 1 divided by 15 times 100. So that will be, it will be returning that. All right, that's what it's going to be reporting. It's going to be returning for us. All right, and next thing is the Pythagorean function. So it returned x squared plus y squared, and it did the square root of that, and 2 and 1, and we find out the hypotenuse. We find out the x squared plus square root of x squared plus y squared between them. We find out the hypotenuse for this function. So the main reason that the professor is showing you that is this, because we can apply this for each of the values of a list. So each of the values of a list can be applied to a function without having to explicitly run through the loop using a loop or something like that. All right, if we run this, we'll get an output of this. Now over here, function year. So if year is 2001 and I printed this, I get 2024 minus 1001. If I did 2004 here, I got 20 because 2024 minus 1004 is 20. Alright, now function to year comma name, it has two parameters, year and name, and return name is string of this plus years old. So a string of 2024 minus year would return to 20 in our case, and then name would return whatever is then specified. So name is John is this much. If I did not mention this name, or let's say I put name 2 here, right, and okay, I can put name there, but let's say I put name 2 here, it will give me an error because name 2 is not defined. It has to be defined. All right, sounds good. Now more about some pandas topics. So we created a data frame. So let's see this df. So it has z and it has k. All right, so let's see if we do df name year that apply function 2. Where is function 2? Okay, I think so. For name is zk and name that apply year function 2. Okay, why is this giving an error? Why do you think? Function 2 is giving us year and name. It is because it is missing one called name. So the give me 1 second. Oops, sorry. So I'll give you guys some time to think while I try to figure this problem out with you guys. All right. So I think it is because it is not being specified in any sort of result. That's why. So what if I do hashtag here and I run this one? See, it worked. So this, the only reason it worked in this one but it didn't work in that one is because we said axis equals to 1. This axis is the thing that made it work. All right. Now case study, you guys did this in class. Can we predict how tall a child will grow based on the height of its parents? Can we do that? We might be able to do it if we have a good data set, but it is kind of random, right? I mean, my mom and dad are very small, but I'm pretty tall, so someone's mom and dad might be tall and they might be tall. Someone's mom and dad might be tall and they might be short. So it's kind of random, but we might be able to predict it up to a certain extent. If you guys want, you could obviously go over Kaggle and see some models that are doing this. But we have a data set here called Galton.csv over here. It has family, father, mother, parent, child, nom, child, and everyone's height. So parent average. So let's see what the professor is here. So if you provided the upper parent and the lower I think height, and if you provided the data frame, it gives you a height of the children. But this is not completely accurate. This is a simple model that he built. So there might be more factors affecting it, so we cannot just say that this is the only way. But from our data set, we can conclude this. All right. Now in this section, I think this is about evaluating the predictions, prediction errors. So these are the things that we could see: min, max count, and I think what he found out at the end was maximum speed for all of these stuffs. He also talked about making pivot tables, which is very important if you are a data science student. Second of all, in this section, we did an old car price analysis. We talked about importing pandas as PD, and then we made some columns here. These are over here, and we read the data and we assigned it a columns. So basically, we rated data that didn't have any columns, and we provided columns to it. That's what this section is doing. We identified some missing values. This is what this section is doing. This not null will say true for whichever one is not null, and it will be false for whichever one is null. So if you see this, it is nan. That is false because it is null. But if it has some data in it, and it will return true. And this is dot sum will just count how many columns. These are the columns. How many values are the sum of each of the columns. And how to deal with missing data, like we saw in the slides, right? In the slides, he did talk about how to deal with missing data over in this section, I believe. So these are all the topics to deal with the missing data, and he said it to drop the data or replace the data. Drop, replace by mean, replace by median, and replace by frequency, or we could drop the whole row. Alright, first we find the average and we replace the nan by average. So everything that is nan would be average. That's one way of doing it. For next thing, we found the mean value for the bore column, and then we replaced it by the mean value. Over here, we replaced by the mean as well, and both ones I think were replaced by mean. I think for this one, he found out the average horsepower and the average peak RPM, and then he replaced it by that as well. For categorical variables, he replaced the ones with the ones that occurs the most, or which is called the mode. Now, simply whichever don't have the price data, I think price data is the one that's the most important. He just dropped it. So our almost we're done with the pre-processing part, but we also have to convert the data in the correct format. Everything is object which we don't like, so we need to change it to float, integer, or something that's good. All right. After this, I think he talked about data standardization, which is basically making the data transform into a smaller version or a common format. It says a common format. So have a look at this Google Colab file, run every code by yourself, and then you will get a better understanding. But basically what he did was L/100 km in the column of highway MPZ. So in the column of highway MPZ, which is this one, how did he change it? Let's say highway MPZ, he changed it to, this was the mile per gallon for this, but this he changed it to for 100 kilometers. So maybe he wanted a highway, like the amount of time the car goes for 100 kilometers instead of mile per gallon, and then he transformed this entire column. Now normalization. All right. So normalization is basically making data follow the Gaussian distribution or the normal distribution. So we want to scale the length, width, and height normal, so their values will be between 0 and 1. So length, I did at max. So let's see. Data is not defined, so let me get the data first. So let me just run all the codes, and we should get up to that data in a bit. Did it work? Did we get an error somewhere? Oh yeah, we get an error here, but we don't need it. So far, we were at the normalization section. So I'm just running all of the code. Okay. So after we got it, we changed the height divided by the maximum height to get a better normal value of the height as well in this section. Now binning is a way to transfer containers into categorical. So let's see what it does. So right now horsepower is 111, 111, 154, 102. But and I think he makes a graph here saying that this is the type of the range of the horsepowers. So he makes bins and he changes it into low, medium, and high. So they just are in the range of low, medium, and high, and then kind of like equal, and then he prints low, medium, and high. So you can see that this data, which was kind of static, is now in different columns, which is basically used for giving good feedbacks, giving more feedbacks about the data. One more column that he made over here. Okay, and it isn't used to label categories. Let's see what this course will do. So diesel, false, 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 gas, true, true, true. Now, all right, so let's see. So fuel type diesel, we replace it to gas, and fuel type diesel, we replace it to diesel. I think it should be the other way around, but because the thing is I already ran it, so that's why it kind of changed it like that. But basically, these is just us renaming the columns here at first. Now we are using an indicator variables called 0 and 1 of true and false. Why do we use it? To basically, instead of saving data as one or the other, we save it as true and false so that if we give a description, we could just, it'll store using less memory, that's why. All right, and if you want to save it, if you want to get the description, you do the data that describes, you give the mean, count, the q1, q3, the 5 number summary of all of the columns. And if you want to save it to a CSV file, it'll give you this is the code to do that. All right, let's see this. It works or not. Wrangle data.csv is saved, and this is the new data that we have. All right, go over this notebook by yourself because it teaches you everything you need to know about Python, pandas, and NumPy for this class. If you have a good understanding of this notebook, if you know every content of it, I think you will be good for the midterm exam as well. All right, this is your TA signing out. Thank you.